Okay, let's take a look at study guide part 3. So find the area of each, use your calculator's value of pi, and round your answer to the nearest tenth. To do this, we're going to need the area formula. Area equals pi, whoopsie, sorry about that. Try that again. Area equals pi r squared. And this formula is found on your formula sheet that you're going to use for the test. So that is given to you. All right, so this first one, number 1, my radius is 10. It is given to me, so all I do is plug that in. Area equals pi times 10 squared. Put that into my calculator, and we get area equals 314.159, and so forth. This says round to the nearest tenth, so that means 1 decimal place. So I would be looking back at the 5 and saying, okay, I need to round up. So area is approximately 314.2. This was going on and on. And I'm sorry, units, we have meters squared. On to the next one, we would do 13.7. Careful on this one. That's the diameter. We need the radius, so we do 13.4, divide it by 2, and we get 6.7. So that is our radius. Then plug that into the formula. Area equals pi, r squared, so 6.7 squared. And let me just plug that in quickly to my calculator, which I can't seem to find pi. Oh, there it is. And we get I get 141.026 and continuing. And again, round to the nearest tenth. So we're looking to cut it off right there. So look back, it is a 2, which means that it is not going to change. So it's going to stay the same. So I would round that to area equals, is approximately, there we go, approximately 141.0, and that would be meters squared. On to the next one. Find the measure of the indicated arc or angle. On this one, we get to use the property that says that an inscribed angle is half the arc. So the relationship is half or double, depending which way you're going. So if I trace this angle right here that we're given, 35 degrees, I see that it intercepts the arc MN. So 35 degrees would be half as big as the arc. So basically take that 35 and double it, you get 70 degrees for the arc. Then I also happen to notice that I have a diameter in my problem right there through the center, which means it cuts my circle in half. So this big arc right here, half the circle, is going to be 180 degrees. If I do some quick subtraction, 180 minus 70, I get 110. That 110 then represents this arc from L to M would be the 110. Then if I look at that and trace back, because the whole point is to find the question mark, if I trace back from L and from M, I see that those actually connect to the angle there. And again, that relationship, the angle is half the arc. So I take the arc and divide it by 2, and I get 55 degrees. On to the next one. Over here, this one is a little bit different, same concept, the angle is half the arc, but if I look at what I'm given here, I have almost all the degrees for the arcs in this one. So if I take the 2 arcs that I'm given and I quickly add them together, I get 230 degrees. And so I know all the arcs in a circle add up to 360. So if I take 360 and subtract the 230 that I know, I get 130 left over. That means this leftover arc right here has to be 130 degrees. Then if I take that and divide it by 2 to get back to the angle, I get 65 degrees. So again, that was take the 130 and divide it by 2, we get 65 degrees. All right, then moving on after I fix this 0 that's really bothering me. Great. Okay, so on to the next one. On this one, we learned a property if you have a quadrilateral inscribed in a circle, the opposite angles are supplementary, which means they add up to 180. So that could help us to find angle T. We'll see. For right now, if I take a look at what I'm given, the two angles, 92 and 70, if I add those two together, I get 162, which means from here to here is 162. If I trace back to the one arrow, sorry. If I trace back to R from those points, then I can get an angle in there. The angle is half the arc, so I would take 162, divide it by 2, I get 81. So my angle is 81 degrees. Then, using that property I mentioned a minute ago, the angles, the two angles opposite each other in an inscribed quadrilateral are supplementary, which means they add up to 180. So I can say x plus 81 equals 180. Then I would subtract 81, and I get x equals 99. All right, on to number 6. This one uses another property we learned. If you have a triangle inscribed in a circle where one of the sides of your triangle is a diameter, then that triangle must be a right triangle. So if that's a right triangle, then I know all the angles in a triangle, regardless, add up to 180. I have 60 and 90. If I add them up and subtract, I end up getting 30 degrees. So this is a 30, 60, 90 triangle. And using, again, that property that the angle is half the arc, if I trace this out to my arc, the arc I'm looking for would be twice as big as the angle 30. So take 30 degrees and multiply it by 2, we get 60. So this would be 60 degrees. All right, on to the next one. All right, so this one, again, we have an inscribed triangle. This time, though, one of the sides of our triangle does not go through the center, so we don't have a diameter, we don't have a right triangle. We do have some angles we can play with, though. We're trying to get to the arc, but remember that's what we're looking for. So I see the angle inside, I know is going to be half as big as the arc, or I can take that 59 degrees and double it, and I get 118. So I know that this arc up here is 118. Then I have two arcs and only one unknown arc for the whole circle. So I can take 118, add the 90, add the 90. And then I get, what do we get here? 208. So that means those two arcs are 208. I know all the degrees in a circle are 360. So if I subtract the 208 that I've already used, then I would get 152. So that tells me that that would be my answer. My unknown arc is 152 degrees. All right, on to number 8. This one, we're trying to find another arc. We're only given one angle. So using that angle, if I trace out the sides to the arc, I know the arc is twice as big as the angle. So I would double it. 45 times 2 is going to give me 90. So this angle, or that arc, excuse me, is 90. Then I look for other things I can do here. What did I see? Oh, there we go. We also, one of those sides I traced also happens to be a diameter. That's important. Always look for those diameters, which means that cuts my circle into half, or that big arc would be 180 degrees. Then if I do the simple subtraction here, take 180 degrees and subtract out the 90, I would get 90 degrees. On to the next one. All right, then we have find arc BC. This one is still using that concept of the angle is half as big as the arc that it intercepts. Or we could say the arc is twice as big as the angle. So to get from the angle to the arc, we typically say we double it or multiply by 2. So I'm going to show that. Multiply the angle by 2, and that is going to equal the arc. So the 2 times the angle equals the arc. Then if I distribute, I get 14x plus 28 equals 18x minus 4. And then solve, I would probably start by subtracting 14x from both sides, but you could do it a different way if you want. Then I get 28 equals 4x minus 4. Add the 4 to both sides. I get 32 equals 4x. Divide both sides by 4. And I end up with x equals 8, which, by the way, is not the answer. The direction said find the measure of arc BC. So arc BC is the one I happen to trace over already. So all I need to do is plug into that little expression. 18 times 8 minus 4 gives me 144 minus 4, or 140 degrees. On to the next one, number 10. This one, I actually don't know that I understand exactly what's being labeled here. It's a little confusing to me. I think the 4x plus 10 is maybe this angle. And the 5x minus 2, I believe, is this angle. If we trace those angles, they happen to intersect the same arc. So if I trace this one back, it intersects that same arc. They both intersect the arc GH. Let me draw that in a different color so we can see that just a little bit better. Okay, so if I trace this back, you see that those intersect the same arc. So if two angles intersect the same arc, we know they have to be congruent. So we would say 5x minus 2 equals 4x plus 10. Then to solve it, I would subtract 4x from both sides. I get x minus 2 equals 10. Then add 2 to both sides. I get x equals 12. Now, again, this is not my answer because the question says to find the measure of arc GH. So this is actually going to take a little bit of work. So I can pick either angle to plug into. I'm going to do the 4x plus 10. So I would say 4 times 12 plus 10. I get 48 plus 10, which equals 58. Then I would need to take that and double it to take it out to the arc. So from the angle out to the arc is going to be double. So take 58 and multiply it by 2. I get 116. So the answer there should be 116 degrees. All right, forward. Find the length of each arc. This requires us to use a formula. We have the central angle over 360 degrees times, since we want the length of the arc, we would times that by 2 pi r. All right, so in this first one, my central angle is given to me, 315 degrees. Oh, let's say area, not area, not area, length, arc length, which is actually given to us with S. It's kind of a weird letter for it. All right, so we have S equals, for arc length, 315 degrees out of over 360 times 2 pi, and then my radius is right here as 15. When we multiply that all the way out, you should get 82.5, looks like, miles. Then on to number 12. It's going to be the same basic thing. I have my angle is given, So the arc length equals 120, whoopsie, 120 over 360 times 2 pi, and this time my radius is 12. And when I multiply that all the way out, you should get 25.1 yards. Forward, find the area of each sector. So this one's going to be a similar formula, but just a little bit different. So we have area equals, again, central angle over 360 times pi r squared. So this first one, my central angle is 60. So I would say area equals 60 over 360 times pi, and my radius is 13 and squared. And again, put that in your calculator, multiply it all out. You should get 88.5 centimeters squared. Then on to the next one. Same basic idea here. Area equals, my central angle is 210 degrees at a 360 times pi. My r this time is 15 and squared. So I get area equals, when I multiply that all out in the calculator, 412.3 kilometers squared. On to the next one. Find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actual diameters. So if it looks like it is, it is. These two don't look like they have any diameters. All right, so we are supposed to be finding RU, which is this one right here. So this is what we're looking for, RU. All right, so with what we're given, we have a central angle and another central angle. With central angles, where the vertex is the center, the angles are equal to the arcs. So this would be 35 from here to here, and this would be 120. Let me do that in a different color rather than that craziness. So again, the angles match the arcs. So this would be 35, and this piece would be 120. So all I have to do to find the whole arc is add those together. So 35 plus 120. Let me write that a little bit differently. A little easier to work with here. 35 plus 120 gives me 155. On to the next one. This one asks for XSU. So angle XSU. So XSU is this whole angle from here to there. Whole angle. XSU. All right, so in order to do this, we're going to need, we have 46, but we really need to know the angle TSU. It's that other part of the angle there. If I take what I do have, I have all the angles but one. I could add them up. Sounds like so much fun. 46 plus, let me do a whole big thing here. So I could take all those angles, 46, 49, 55, 100, add them all up, which I'm going to do on my calculator really quickly. Bear with me. 46 plus 49 plus 55 plus 100 equals 250. Then I can subtract that from 360 to find the missing angle. And I get 110. So my missing angle in here is 110. So if I take the two angles and add them together, I would get 110 plus 46, and that gives me 156 degrees. All right, onwards. Number 17. This one, find the measure of arc GCE. So GCE, I start at G, go to C, continue all the way around to E. So that one I didn't really need, didn't really need the arrow. So G, C to E. The only thing I'm missing here is the arc ED or DE, whichever way you want to call it. So if I can take what I do have, I have all the arcs but that one, I can add them up again. So 45, 55, oopsie, 100, 125, add those all up, and once again, bear with me while I put that in my calculator. 45 plus 55 plus 100 plus 125, I get 325. So that's the total for all the arcs except the one that's the ED. So then I would take that and subtract it from 360. And I get 35 degrees. So my unknown arc is 35 degrees. Then I can take the actual arcs that I would like and add those together. So 100, 125, and 135. Not 135, excuse me. Just 35. There we go. Okay, add those together. So let me do that really quickly. 125 plus 100 plus 35, we get 260. And that would be our answer. Next one, number 18. This one, we actually have a diameter, so let's make sure we're clear on that. We have one right there. We also have a second one. And this one, we also have a diameter here. So two different ways to cut our circle using the red or using the blue. We're asked to find, let's see what we're asked to find, what measure of angle YTU. So YTU is this right here. YTU, it's this angle. So with what we're given, a couple of ways we can go about that. We can take, if I split my circle using the red line, so I'm going to use some red colors here. Red, I can add 44 plus 71, and I get 115. Sorry. There we go. Okay, so I get 115. And again, if I'm cutting it on the red line, then if I take that 115 and subtract it from, not 360, excuse me, half a circle here, subtract it from 180, then that will give me 65. So that gives me this piece right here would be 65. Then if I do that same concept with the blue line and take the 180 and subtract the 65 that I know, and actually, yeah, 65 that I know, I would get, sorry, I don't know why this was confusing for me, 115, there we go. So that 115 would be this piece right here. Then if I take, this is the arc, but I'm looking for the central angle, the arc and the angle will be equal. So this would equal 115. So again, that's a central angle. It's different than our inscribed angles that we looked at before. So that would be, again, 115. All right, forward on to number 19. Convert each degree measure into radians. To make it into radians, we would multiply by pi over 180. So pi over 180. Do not multiply pi into your calculator or you will get this wrong. So we want to basically multiply straight across. So I have 255 pi over 180. What I'm looking for here is some way to reduce. It looks like I can divide top and bottom by 5. So 255 divided by 5, I get 51. And 180 divided by 5, I get 36. Don't forget your pi, that was still in the top. And if I look at those, it doesn't at first look like I'll be able to reduce, but both of those are actually divisible by 3. Whoopsie. So if I do that one more time, I get 17 pi over 12, which is the answer. All right, for the 120, same basic thing. I'm going to multiply it by pi over 180. And I didn't mention this, but we want to make that first number into a fraction, so it makes our multiplying easier. Go straight across. I get 120 pi over 180. Then I look for things to cancel. If I divide top and bottom by 10, those zeros are going to basically cancel out. Then I'm looking at 12 and 18, which are both divisible by 6. 12 divided by 6 gives me 2, and still the pi. 18 divided by 6 gives me 3, and there's my answer, 2 pi over 3. All right, the last ones here, we are turning these into degrees. We're going to be multiplying by 180 over pi. So 180 over pi, again, not so much using the calculator for the pi calculation. We don't care about that because you'll notice right here, the pi's cancel out. And we can go straight across. Or if you know how to cross cancel, you can cross cancel the 3 and the 180. I think it's easier to cancel. 3 goes into 3 once and into 180 60 times. You could do that on your calculator if you weren't sure. And then multiply across. 60 times 11 is 660 degrees. All right, then pi over 4. Again, multiply that by 180 over pi. Again, the pi's cancel. 4 actually goes into 180, so 4 goes into 4 once and into 180 45 times, which gives us 45 degrees for our answer. And that's it for part 3.